when we put the ICMJ, which is far more than just judging, as you can see online, then someone has to run the first webinar. So I guess I was lucky to be chosen for that, and it's fantastic to have such a great turnout today. This presentation is about the work we've been doing with the Advanced Livestock Measurement Technologies project, and Sarah Stewart, Dave Pethick and myself have been managing the program 2, which is the measurement of eating quality traits or meat quality traits. So today we're going to, today I'm going to run through an update on the cut surface grading technologies, and then I'll hand over to Jazzy to talk about the commercial application of grading technology into their plan at Wagga, and then I'll follow up with a look at the new technologies under development within the industry that we've been working on over the past 3 years. The first thing I want to outline today is what drives the success of a technology. Now, that technology down here at the bottom of the screen is something that I'm pretty passionate about, and I feel that I'll be able to go to work in one of these things by the time I retire, which is, you know, hopefully another 30 odd years away. But that quadcopter, personalized quadcopter, let's have a look at these things, whether it's going to be successful or not. Is there a need or an issue? Well, in the cities there is, because roads are actually a terrible place to drive because they're two-dimensional. You can't bunny hop over the top of other cars. And so if we take to the skies, we're in a three-dimensional space. There's a few issues around that, but yeah, we've got congestion, people are getting time poor, etc. Do we have the ability to build these things? Yeah, they're already built. Is there systems in place to make them work? Can they communicate with each other, tell each other where they are, so we don't have a whole heap of these drones up in the sky crashing? That's where this technology falls down at present. None of those systems are in place around the world to allow this technology to work. And is the cost benefit there? Probably not at this stage either. So this technology is a little way off, a bit like Dick Tracy's watch back from 1956, and then the Google watch was released in 2016. So some technologies take a long time to release. So, but what drives the success of a technology is simply those 4 things. And that technology the journey of a technology is in 4 distinct stages, and each can take months to years. So I'm going to put into context here where research fits in, where the private companies fit in, etc. So the first phase is around development. So someone has a light bulb moment and says, hey, I reckon we can use this to measure this. And then we move into the validation phase. So there's a bit of research in the development phase, but a lot of research into the validation phase. So can that technology that's been developed actually measure what it says it can measure? Well, once we prove that it can, and it gets through all the accreditation phases, then it can move into commercialization. Then the developers have to work on, you know, who's going to buy it, where are they going to put it, when do they use it, how's it going to be updated, etc. That commercialization. And Jazzy's going to talk about this phase and the implementation phase with the T's experience for the E+V camera today. So the parts I'm going to be largely talking about is the phases we work in ArmTech, which is phases 1 and 2. Now, this is not a rapid or cheap process, and it takes good collaboration between companies and researchers and the tech companies themselves. So we lose control of it at some points in time. It's not just research. It's not just private companies that are driving these things. We all have to rely on each other. I'm just going to delve a bit into developing a device and how we get them to be accurate. And so the first thing we have to do is train them, or what we call training or calibration data. And this data helps us generate an equation. And the equation is between the actual trait value and the value that is given by the technology. So some technologies require a little bit of training and calibration. Some require heaps of training and calibration data. But once we get that relationship between the actual trait value and the text trait value pretty good, then we move what's called into validation. So we can do cross-validation, which you split the data set, train in some, test in the others, and then repeat for all the remaining sub-data sets. So this tells you about, if we take this equation and put it into other unknown data sets, does it work? So that's one way we do it. The other thing we have to do is independent validation. So we put the technologies across a trait, and then they've never seen the data before. So we have a independent validation, and from that we look at the precision, so that's the R squared, so how much variation does the tech trait explain out of the actual trait, and then root mean square of the error of, and sometimes it's RMSEP, which is root mean square of the error of the prediction. Basically, how close does it get to the actual is what that number means, and R squared is how much variation does it explain. The other thing we look at is the accuracy. So if that slope tilts over or pops up, that's what we call bias and slope. So we look at the accuracy of technologies as well. And the transportability is actually what is key for a technology. Doing this step, the training and validation, calibration, is quite easy. Doing these steps, of course, much harder. So making it be accurate in an unknown data set is much harder. Now, in terms of when technologies hit the media space, a lot of the time we see technologies when they're simply in training or calibration phase. And I'm going to show you a few of those technologies today. And we can get really excited about them. But when we get more and more excited is when they can go into new data sets and perform equally as well, or not lose too much accuracy. So we've got to be mindful of that when we read things about new technologies. Where are they in that journey? So the devices I'm going to cover off quickly today before I hand over to Jasmine is the Frontmatec loin eye camera, the MIJ, so the medium imaging Japan camera, the VIAScan CAS system, the Masterbeef system, which you can see here, and then the E+V system, which Jasmine will also talk about. So these are cut surface devices. We call them cut surface devices because they look at the quartering site in a beef carcass, like you can see there. So to do that, we need to measure lots of traits in this cut surface for either osmic grading or MSA grading, so we can determine our levels of MSA. So that's a pretty handy little Angus carcass there. So the traits we need them to measure is rib fat depth. Now that's a tricky one. MSA marbling and osmic marble score, the meat colour of that loin eye, the eye muscle area, and the fat colour. Now some of you might be saying, well, eye muscle area doesn't have any impact on eating quality, and you're right, it doesn't. But to get all these other traits, the technologies have actually got to be very good at tracing around that eye muscle, because you don't want to take in this as eye muscle area or that as marbling. So they've got to get this trait very accurate to be able to nail these other 4 traits. Now the hardest one of those traits is rib fat depth or subcutaneous fat depth, because you can see that cheeky little line there. It's very hard to pick up that line. So there's not been as much focus on rib fat depth as those other terms. So what's our current practice? Well, we use human graders. Now we all either know this or I'm going to tell you now, but the grader goes in sometime in the middle of the night or early in the morning, and they simply push through carcasses or at a grading station. Now they've got lots of things. They've got their meat colour chips, fat colour chips, pH meters, their little computer here that they punch all their data into, their light, etc. So this, you know, there's trying conditions, and to be fair, humans are humans. You know, we're all good one day, bad the next. And if you don't believe in that, just check out the performance of your rugby team or your AFL team to understand that humans are humans. But humans are actually the best technology we've currently got to do this job, because there has been to this point in time no technologies to do that. So the real question is, can cameras assist these graders to do their job better? And that's where we're really at with bringing technologies into grading. Is we're not really replacing graders, because they will still have to use the cameras and override some of those terms if they don't absolutely agree. Plus, there's a whole heap of times where this cut surface is not nice. It might be slumped or cut or, you know, soft-sided, etc. So that eye muscle might be trash, which is when the graders are really important to deal with that those overrides that are needed. So why are we interested in, even if they're as good as we've got, why are we interested in humans? Well, I'm going to show you a little bit of data here, which relates to greater variability. So we did an experiment where we measured the same carcasses at 6 different time points, and we're looking at the effect of time and temperature to grading on marble scores. Don't worry about that. Between these 36-hour and 48-hour time points, the same graders, so graders A, B, and C, graded exactly the same 140 odd carcasses. And what we can see is that their scores were not perfectly the same for each carcass for those 2 grading time points, because if they were, the difference would be around 0 and their standard deviation would be 0. But we know that. We know humans are humans. Now the value, we also, at those 6 time points, took a camera score on those exact same carcasses, and its standard deviation, which you can see here, was 37. So about 40% smaller than what we got out of the 3 human graders. So that is really reducing the variability between time points or between animals, between plants, is where the value is. And I think Jasmine will cover off on some of that later on. But this is where the true value of cameras comes in, is we can give the same score consistently day after day across plants, across seasons, into those important brands that we produce. So now on to a few of the cameras. We've first up the Frontmatec loin eye camera. This is a hyperspectral camera. So that's just a fancy term for saying it takes multiple images at different wavelengths, okay? So don't get confused by that. So it takes 6 different images, and you can see there, that's the same loin eye. It takes them very quickly. So this is a prototype device. It's connected here to a computer. So of course that's not feasible to be carrying around. But for that development phase and validation phase, that type of prototype is all that's needed. So we'll just have a quick look at a little bit of data. So this is the actual ribeye of these animals that we've used and the predicted from the camera. And you can see that the R-squared is pretty high at 0.83. The slope is pretty close to 1. So it does a pretty good job of eye muscle area. Same with MSA marble score. So this is the actual marble score from 1 or multiple graders, and the predicted MSA marble score with a R-squared of 0.75. Now this is in their validated data sets, not in their calibrating or training data sets. This is in the validated data sets. So that's transported out. So that's quite a good result. These guys also get very similar results for osmeat marble, meat color, and fat color. And they're confident enough that all their traits will meet or are close to meeting the osmeat accreditation guidelines with that prototype. So what did they do with that information? Well, they went away to their board. So they're a huge company that develop all sorts of things. They've just put in the new kill floor and boning room at Sunpork in Queensland. They've got massive amounts of technology going on, but they're a board approved the commercial development of their hyperspectral loin eye camera. So that's where that technology is currently up to. And it should be back, that commercial camera should be back in Australia towards the back end of this year for more training and validation. Now to the Media Imaging Japan camera. We've seen a lot of this camera over the past few years, and we've worked with it extensively over that time. And we were chasing some traits like the distribution and fineness of marbling in the multiple Angus cohorts to see if those traits were heritable. And so we've got enough data on that to know that those traits are heritable. So it's been a great camera to do that work. They've developed their algorithms for MSA and osmeat marbling traits. For a long time, it was only spitting out osmeat traits. They've now developed their algorithms for MSA traits on 1,200 carcasses on 7 different data sets. They've done some independent validation across another 13 data sets or 800 animals. And what that shows is that their cameras are actually good. They've got low variation between cameras. So it means it gives the same score quite consistently. And this is images from that time by temp work. But they do have some further work to do on training data to improve those algorithms for their MSA traits. So they've got huge data sets available for them to continue training and calibrating this camera. The VIAScan camera is a new one that's come back. Well, it's not new, but it's come back on the scene, which is fantastic. Last year in 2019 or back end of 2018. And it's a camera produced by Cedar Creek Company, and they've been taken over by the huge company called Morel. So that's an Icelandic company, really big in the processing space. And Cedar Creek has offered them a few new bits of kit to put in their box of tricks. So this camera is an RGB, so a red, green, blue vision camera. It's handheld already, battery operated. It's been doing osmic traits for some time, and it was already in place in a couple of plants, the old Cargill plants many years ago to grade for Woolworths. But they're constantly upgrading their calibration analysis and also developing those new traits, the MSA traits that it hasn't done. So just a bit of its performance from a couple of data sets we did. And you can see here that the tightness or the accuracy of prediction on those traits is pretty good. And they got adequate quantities in their validating data sets into those equal traits, 1 out and 2 out, to go for osmite accreditation. So where are we at with this camera? These guys, Cedar Creek Company, have got a very strong commercial focus. They're a big company. They've been in the game for a long time, so they know how to operate. There's updates to hardware and software continuing to make this device more accurate and better and easier to use. And we're working with this company to do more repeatability trials to look at the variation between the cameras, and then move towards osmite accreditation with this camera as well. A new one to the suite of technologies that for ArmTech is the Masterbeef Camera. And this was being developed by Darren Hamlin, and Darren's online today, so thanks for joining us, Darren. Darren was chasing basically improved accuracy of data into his genetic databases. So that's why he built this device for his own databases, to make sure that the data going in was better than he was getting from the graders. And it uses a Google Pixel 2, 3, or 4 camera, or an Samsung A70, or I think there's another Samsung one it uses as well, and I think it's in development for the iPhone as well. And then on those phones you get the Masterbeef 3 app, which you can download. So in brief, at this point in time, it spits out a nice suite of data, and you can see the long string of data here, but it is IMF, percent, osmic marble score, EMA, marble fineness, distribution, meat color, fat color. So the work we're going to do with Darren and his team at Masterbeef is get them some images with some MSA marbling information on those images, so they can develop that measurement as well, calibrate and validate all those traits, and then look at the repeatability between the Masterbeef systems, or set up experiments to do that, and also move this technology towards osmite accreditation as quick as we can, and COVID restrictions lift. The last camera I'm going to talk about, and Jazz is going to talk about this one much more, is the E+V camera. So they're approved, or they've had a preliminary approval for osmic marble score 0 to 5, MSA marble score 100 to 700 only, meat color traits and fat color traits. And their final approval experiment was meant to go ahead at the back end of March. So that was canned due to COVID. So we've done a lot of work with osmite and other crew to work out what camera needs to do to get accredited. And so, yeah, it'd be great to hand over to Jazzy now to work through the commercialization of such a device. Can take some questions though, while Jasmine's getting set up, if there is any.
Pete, there was one via the chat room saying you just show the human graders give more variable results than the camera, but then human collected marbling data was used to validate the marbling data produced by the camera. Can you explain how that works?
Yeah. And that's the complexity. That's the complexity of the job we've got, right? So if you train data, if you train a camera, the best we can do is train it to be as accurate as our best graders. And we can't get more accurate than our best graders because it's impossible, because it's a moving target for. So what we have to do is just that. So we have to work out how accurate are our best graders, and then the cameras have to be as accurate as them. But you've highlighted one of the tricky bits of this whole work, is that trying to train a technology on a variable human is difficult. And so we utilize multiple graders is one way we can do it. And then we can throw out those carcass traits where the graders don't agree. That's one way we've got around that. I'm good.
Thanks, Pete. We don't have any other questions at this stage, so we can carry on with Jasmine, and then we'll come back at the end with some more. Oh, sorry, no, we do have one. How do you determine how much data you need to make the machine accurate?
Yeah, good question. And that's very dependent on the technology that and the analytical methods that they use to develop their algorithms. So some that use very basic linear algorithms probably take a lot more than others, and some that are using neural networks might take, you know, thousands and thousands to make those work. So that also, there's no defined amount that people need to do that. It really depends on their analytical, the way they develop their algorithms.
Great, thanks, Pete. I'll save another one for the end for you.
No worries.
Rightio, everyone. So I guess I've been invited by the ICMJ committee to share a little bit of an insight into our journey at TEAS around the commercial application of some of this grading technology that Peter's mentioned. So just before I get into the presentation, I'd just like to say a very big thank you to the ICMJ committee for the invitation to be involved in the first of their webinar series, and really looking forward to what else they're going to deliver through their digital platforms as we move through COVID this year. So I guess when we talk about beef carcass grading, not all carcasses are created equal. So the capture of the grading information against the individual carcass that Pete mentioned earlier allows us as a business to be able to sort those carcasses into suitable processing runs of similar categories and eating quality under our brands. So this makes sure that when we're sending that carton of beef to our customer or consumer, that all of those pieces in that box are going to have the same eating quality, and the customer is going to get that same eating experience each time. The other benefit of this grading information is it also allows us to provide feedback to producers, and this information can obviously help them make more informed decisions on farm. So things like, do my cattle have the correct amount of finish to meet the required market specifications? Or do I have any dark cutters, and what potentially might be causing those to cause that reduced eating quality in those animals? So we're really fortunate in Australia that we have the MSA grading system, which is a world-leading system on measuring eating quality on beef carcasses. And I guess in terms of why is this important, it's definitely all about eating quality. So we want to make sure that by using this grading, that we're providing that consistent eating experience for our consumer. And all of our brands, there's a couple of them listed down the side there, are underpinned by the MSA grading system to ensure that we can actually provide that eating quality guarantee to our customers. And of course, beef's a reasonably expensive protein around the world, and we want to make sure that we're getting those repeat sales from those consumers. So being able to provide that consistency and repeatability of that eating experience in that product that we sell is really important to help make sure we can meet our customers' expectations. So Pete touched on it before, but there's obviously been quite a few calls from across industry on looking at ways on how we could actually provide more objective measures around carcass grading. And Pete's mentioned there's a range of various technologies out there. And today I'm just going to share some of our journey and just how we've looked at applying some of these technologies into more of a commercial environment. So camera grading or machine grading for quality is actually relatively common in the US. And there's several technologies that are actually approved under the USDA grading system over there. So these instruments are able to measure several different variables that are present in that exposed ribeye area surface, and these are then used in the USDA quality grading of the carcasses in a majority of plants in the USA. So one of those technologies that Pete mentioned at the end of his presentation there is the VBG 2000 grading camera. So this was actually developed by the USDA and commercialized by the E+V technology in Germany. So I guess from our perspective as a company in Australia, is we're looking for something that obviously is already has the runs on the board and is proven ready to go commercially. So the attraction for these particular cameras for us was they'd actually already been designed for quality grading of beef carcasses, and they've successfully implemented these into those commercial settings in US plants. So a lot of those US plants, some of those are processing up to 5,000 head a day. So those cameras are obviously robust enough to be able to cope with those sorts of conditions. And obviously, as Pete mentioned before too, we need to make sure those cameras, when you take them out of that prototype stage into a commercial setting, they're robust enough in their design to put up with that extended use and also cope with those harsh environmental conditions in those chillers. So they're quite cold, so the technology needs to be able to work in those cold conditions, and also be able to be really easy and simple to clean, to make sure that we're still maintaining all our food safety and hygiene as well. So I guess it's not quite as simple as just bringing a camera over and plugging it into a plant in Australia and away you go. The E+V camera in the US was obviously set up to be able to provide all the outputs in terms of a USDA grading score. So your USDA prime, choice or select, which obviously isn't as applicable under our grading systems in how we sell and market our beef here in Australia. So one of the things that we've initially had to do was actually develop a suitable process to effectively train or calibrate, as Pete mentioned, this camera technology on how to actually do those OSMET and MSA carcass assessments. So we need to be able to actually convert it across, rather than giving us a USDA quality grade. We need it to be able to give us an OSMET and MSA marble score, OSMET and a MEQ colour and a fat colour as under the OSMET language standard definitions. So there's obviously a lot of work that Pete mentioned that has gone into that. So I guess here's just a quick image of some of the validation work that we did. So there were several trials which were developed to collect data and train those algorithms, and we actually went through those processes that Pete talked about in terms of collecting some data and then actually using that to design the algorithm and then test that against some other data sets as well to ensure that the output is actually working correctly and providing the correct grading score. So we did quite a number of trials, which included grading over about 14,000 head. 1,400 head, and in that we've also done quite a few studies around the accuracy and repeatability of those cameras as well. So there's 3 different cameras. We also had 2 independent MSA graders as well as our company graders. So between all those different collection points, we've collected about 50,000 different data points within those trials. So there's quite a lot of information to get through to be able to validate and check and balance and make sure the outputs these cameras are providing are accurate. So I guess these trials were also designed, as I mentioned before, to be able to show that both the repeatability and accuracy of those grading tools. So part of that is within the camera itself. So making sure that it actually gives you the same result each time. So some of these trials were designed around taking an image of the carcass, taking the camera off, putting it back on again and re-imaging it to make sure it actually gave you the same outcome each time, and then also between cameras. So actually doing several studies with multiple cameras, all imaging the same carcasses and making sure there's consistency across the output that each of those cameras are giving. So in that photo there, you can definitely clearly see 2 of those cameras there on the grading stand. There's actually a 3rd camera right up the end. So again, there's obviously real estate's quite limited in a lot of processing plants. So being able to do these validation studies can be quite tricky because a lot of these plants aren't really set up for for this research and development work. So trying to actually find enough space to be able to test and validate these cameras when you're working with that many of them. It does also provide plenty of challenges for our team as well. So the results from all these grading cameras, all those data collection points will then match back to those independent graders from MSA, and then all of that information was actually provided to an independent statistician for an analysis. So there's quite a huge amount of work that's gone into the validation part of that to get those cameras set up for our Australian grading systems. So once we were happy that those cameras were able to provide the correct outputs under that AusMeet language, all of that trial data was actually provided to the Australian Meat Industry Language and Standards Committee for review. So for those of you that aren't aware, this committee is made up a number of representatives across the industry, and they assess the suitability of various technologies and sort of give them the approval of the go-ahead to be able to be used under Australian grading systems. So this obviously not only included the initial trial work and validation work that we did, but also actually includes some audit and verification visits. So we've actually undergone a desktop and site verification audit from AusMeet as well, which also includes all of our process and training records. So making sure that we have a standardised process around the training for the camera operators, and also things around the calibration process and our startup functions daily to make sure that that camera is working correctly each day when we go to start up the process. So as sort of Pete mentioned before, and hopefully this gives you a little bit of an insight into it's quite a lengthy process, and there's multiple checks and balances along the way to help ensure that the technology is actually suitable for the application. In this case, making sure it's got that accuracy and repeatability that we've been looking for. So I guess how does the camera actually work? I didn't want to share a video today, just I wasn't sure how we would go with the bandwidth. So I'll just talk you through the process here, but similar to the normal chiller assessment process that Pete mentioned earlier, the Carcass ID is recorded, so usually the Carcass ticket barcode is scanned, and then the camera is operated by a qualified chiller assessor. So there's always a trained grader operating that camera grading unit. So they place that camera nose there over that ribeye area, and the camera records an image of that ribeye and analyzes that required grading information, which includes the marbling, meat colour and fat colour outputs. So you can see them coming up on the screen there. On the left-hand side of that screen, you've got all the outputs that camera has recorded for that particular carcass. You've also got sort of a raw image there, so you can see and sort of make sure that that's presenting the right type of image. And there's also the image on the right-hand side, which kind of gives you a visualization of how it's analysed that image. So this output can be accepted by the grader, and the carcass continues on down the line, or the grader actually has the ability to override the grading output from the camera if they believe that it's not valid for some reason. So there is actually a number of built-in checks in this system and warnings for the operator to let them know if there's things like bone dust or water pockets that could actually affect the image. Or also, as Pete mentioned, if that carcass hasn't been presented in a suitable way. So we do need that clear ribeye surface to be able to grade those carcasses with this particular type of technology. So as Pete mentioned, the grading camera has approval for AusMeet marbling and MSA marbling, meat colour and fat colour. There is obviously a number of other traits in the MSA grading model, such as pH, hump height, fat distribution and ossification. But this camera is only able to actually grade those particular traits that it observes in that exposed ribeye area. So a lot of those other traits still need to be assessed by those human graders. So I guess in terms of the next steps for us, as Pete mentioned, we're in the final stages of approval for that VBG 2000 camera at our Tees Wagga facility. So we still have one final review stage, which is meant to be an on-site verification, which COVID sort of has put the halt on that a little bit. So once those rules around travel requirements and visiting different locations get lifted a little bit, we'll hopefully be able to get that completed. And we're also in the process of just finalising that flow of that grading information into our feedback system. So once we get that final sign-off, we'll actually be able to provide that grading information directly onto those feedback sheets, just in the same way that the MSO grading information currently does. And obviously, as I mentioned before, there's this grading process is always going to be audited on a regular basis, the same as any other grader would be as well. So I guess the next steps for TEAS is, once we get the Wagga site online, we'll actually be looking at installing this technology at a number of our other sites. Obviously, there's been some delays in that process around the COVID situation, and each of our sites is actually set up quite differently in terms of their layout, so we will need to spend some time just making sure we can actually apply this appropriately into each situation. But we're certainly really excited about how we can use this technology to help assist our graders with their tasks, and also help us providing those objective carcass measurements that people are looking for. And I'm really keen to hear from Pete in the next session here on what else might be in the pipeline for the future. So I guess I hope that there was quite a brief insight into our journey into objective carcass measurement. But if you'd like any further information, my contact details are there on the screen. But just to say a very big thank you to the ICMJ committee for all the work that they do in terms of supporting the development of young people into our industry. And well, thank you, and I'll hand back over to Kiri.
Thanks, Jasmine. That was really interesting. We've had a couple of questions come in, and this might be for either you or Pete. Firstly, there's a good question from Jessica Schilling. How will human grader skill levels be maintained when these technologies come in? So you've got new graders coming into the system that don't have that experience behind them, and they only start using cameras. If you ever have a situation where the cameras go down, how do you make sure that if you're getting manual grading, that your standard's still quite high?
Yep, great question. And that's, I guess, what we've selected to do is make sure we always have accredited graders. So they still need to undergo all the same training as a normal grader would with their process, and that will include that normal calibration or validation process that they complete. So they still, all the current human graders still have to do their OSCAP correlations every 6 weeks. They'll still have to actually do that process to and make sure that they're current, because we only can have accredited graders using those grading cameras. Because definitely there's always a need to have a workaround or have a backup plan for some reason if something does go wrong. You still want to be able to do that, or in those instances we have a carcass present that we can't actually grade with the camera because that ribeye surface isn't appropriate for that technology to be used. But
yeah, great answer, thanks Jasmine. And another quick one, do the cameras save much time in grading process? It makes it more accurate obviously, but does it slow down any of the speed in the grading process?
So the time for it to capture and actually provide that output is like 0.25 seconds. To 0.25 of a second, so it's quite fast in how it's actually able to collect that. So I guess in terms of the normal grading process, by the time the grader has to move his chips around and make sure he's got his torch held in the right spot, it definitely does save us some time. We see in the US experience, they're actually grading sort of up to 5,000 head a day through some of those plants. So their change speeds are obviously a lot faster than what we're used to experiencing. So it's definitely will help speed that part of their job up and allow them to be able to focus on some of those other traits as well.
Perfect. Thanks, Jasmine. And I see we're back on with Pete, so we'll run with the rest of Pete's presentation, and then we'll come back to some questions at the end. Thanks very much.
Now you can keep going, mate, if you want to take another one while they're hot.
Well, the other question is, what is the cost difference between setting up the system and just using human graders? Might not.
That's a really good question. I actually don't have that in front of me, so I probably can't answer that one on the spot, sorry. But I guess in terms of us, the cost, obviously there's hopefully a reduction in labour units potentially. We still obviously need a human to do that grading, but hopefully the camera you don't have to give it rostered days off, you don't have to give it annual leave. So there's obviously a few things there that we don't have that we do with humans, so it does potentially allow us to run with slightly less graders than what we would normally. Obviously not everyone wants to get up and come into the chillers at 2 o'clock in the morning, so it is quite difficult sometimes to find people that do want to do that job. So I guess there is definitely some benefits there in terms of making it easier for those graders who do have those skills and want to come in.
Yeah.
Jazzy, would you agree that then that's the, I guess, the direct cost you can look at, and you know, how many graders do you need at Wagga compared to when you have cameras there? But the real cost that's hard to get a handle on is the value of consistency into your brands. Would that not be, you know, that's where the big value for teas is coming from?
Definitely. And as I mentioned at the start of my presentation, making sure we have that consistency of what's going into those cartons for our customer. Again, it is quite hard to put a value on that in terms of a cost benefit analysis, but it's really, really important in terms of making sure we get those repeat sales. And it's a very competitive environment out there in terms of selling beef, particularly at the premium level, which Australia needs to operate at. So making sure that we're getting that really consistent eating quality is really fundamental to making sure we can get that value.
Yeah, I'd love to put a dollar sign on that one day with you if if it was possible. But all right, any further questions, Kiri?
At this stage, Pete, go ahead and then we'll see what we get at the end. Like all good ICMJ, there's always good questions that make us run over time, so we'll see how we go. That's
all right. I've only got another 40 slides, I think, but no, just kidding. Don't all jump off. There's only about 18. So back to this one here and what drives success for technology. I'm moving into an area now of technologies that are really in the development phase, calibration phase. And one need we have is the measurement of lamb IMF, or intramuscular fat, or marbling in lamb. That is a huge industry need. And so we're really working hard on this to develop the ability to do this, and then of course systems in place to do it and make value out of it through the MSA lamb-based system. So I'm going to run through a few technologies now I've been playing with to try and measure IMF in lamb. And the first one is Soma NIR. So Soma is a company out of Japan, and they've got this technology already, which is a near-infrared technology. For measuring the amount of fat in tuna meat. Okay, so when we measure it, we use it here on our lambs. It already gives us a number, but the number doesn't make much sense because it's for tuna, not for lamb. So we have to train that device to measure what we want it to measure. So they did some great work over in Western Australia earlier this year, and you can see the team here with the big ram. Everyone loves a picture with a big something in Australia, right? And they measured hot topsides and cold loin things. This technology does require the fat to be taken off a surface or a cut surface. And they did a couple of scans on that. And we're going to further capture more data. They're going to send out one of these devices for us to continue calibrating and validating this technology in lamb kills that are coming up. So a bit of results from that early work. It actually worked quite well in topside. So you can see here that the actual score versus the Soma score. And as one goes up, the other one goes up, and explained about 52% of variation. So that was good. Of course, this is training data, and this was in the topside. Now, why the hell would we want to measure the topside? Well, it's because the topside IMF is correlated with the loin IMF, and you can't see the loin at this point in time when a lamb first goes into the chiller. So if we can get an early indication of IMF on these animals, maybe we can use that information to sort carcasses. So that's why we're mucking around with the topside, not because it's good to eat or anything like that. It's actually quite the opposite. But it also worked well in the loin. So this is the cold measures. You can see the R squared is 0.42. It was pretty accurate. So the root mean square of the error of prediction is 0.7. And the rule for all technologies is that each new technology has to be better than the current one. So the current technology for measuring IMF in lamb doesn't exist. So are these scores better than 0? Yeah, they are. So these technologies to measure IMF in lamb are progressing, but there's a race on. So the other one that's been having a crack at that was the Frontmatec loin eye camera. So they've imaged lots of 1,200 odd lamb images. The results are pending on these, but the image analysis is far more challenging than in beef. This hardware was designed for beef, so the shroud is quite big. Segmentation of EMA for the lamb is difficult, and just due to the nature of lamb, small errors have a large effect, right? Whereas beef, if you're 1 centimetre out in a lamb EMA, it's a big deal. If you're 1 centimetre out in a beef EMA, who cares? It's a small percentage. So that's the difficulty with lamb as well. We continue to work with the MEQ Probe, and Geordie's online today, and thanks for joining us. But this probe has been around for a couple of years and continues to be developed. So it's changed hardware again. It's now got 2 probes, and they've got a much wider spectra range. So they look at a much wider range of light that gets absorbed. They're constantly updating their software, and they've captured lots of information on resource flock lambs and other beef animals as well. They've got a current MLA project for development of this, and they've got a new project from Australian Meat Processors Corporation to continue with that. But I'm excited to see some fresh results out of this technology come October. I think it'll be good to see where they're at in terms of accuracies. Another really cool one that we've been playing with in the last year is one that's been developed by Rob McLaughlin at the Centre for Nanoscience Biophotonics at the University of Adelaide. And this is called Optical Coherence Tomography. So it's a really fine needle, and they use it in humans for doing brain surgeries. So this technology, the needle goes in, and they're looking for the margin between your brain and a blood vessel. Because if you're taking out pieces of brain, it's not very useful to cut a large blood vessel when you're doing that. It kind of ends in death. So this technology is very important for them to do that. And the brain is fat, and the blood is protein. So these guys got together and said, well, we should be able to look at the amount of IMF in lamb meat as well. This can't be too much of a hassle. So the optical coherence tomography technology basically is in a stainless steel needle, a very thin needle at this point in time, because you wouldn't want too much bigger than that going into your brain. It's got an optical fibre coming down to a miniaturised lens, and it's got an imaging window out the side. So it looks at the light going out and the light coming in. It's very fine at this point in time. But the opportunity is that it should be able to scan hot carcasses, maybe does better in cold carcasses. And if the needle's fine enough, maybe in live animals as well. But don't get too carried away with that one, because obviously there's some ethical issues sticking needles into things. But it's this needle's attached to the mini probe here and to the computer. So what does it look like? It scans when you pull the needle out of the meat. And you can see here these black shadows. That's and the white bits that are before the shadow. So that's the intramuscular fat. And they simply look at the amount of those white specks in a very fancy way to give us the percentage of intramuscular fat. So from the first couple of 100 lambs they measured, this was the relationship between their IMF estimate using optical coherence tomography and the NIR measurement from the lab. So there was a pretty good R-squared, not much slope, not much bias. So this gave them confidence to say, hey, this technology's got merit. So don't forget, we're at the development phase of this technology. So the OCT needle technology has potential, as we said. The needle penetration into the loin will allow for probably better analysis of IMF, because you're not just looking at this surface IMF, you're getting a much deeper look at that IMF. So it might be useful in beef systems and stuff as well, rather than just looking at the top 1 or 2 millimeters. Rob and his team are pretty confident that they can get the accuracy of prediction down to less than 1% using some deep learning algorithms. So this first pass was not using as sophisticated analytical techniques. And I think once they develop their commercial product, which is what's happening now, that some deep learning algorithms will help them get more and more accurate in predicting IMF in lamb. So that's a pretty cool technology. The other fun one we've been working with is nuclear magnetic resonance, and I think Donald's on here today, so thanks for joining us as well, Donald. But this is a pretty cool technology. So Donald and Evan came over with their NMR, so technology, it runs at that. We measured a couple of 100 resource flock lambs, and at this point in time, this prototype took a 12 to 18 grain sample of meat. So we took that off the front of the loin and stuck that into the little cup. So it goes into this cup here, and this is Oscar, who said scientists don't have a sense of humour. The NMR machine's called Oscar because he's stuck in a garbage bin. And this thing's been down to Antarctica early in its life to look at the amount of CO2 in the ice cap down on Antarctica. So, and now it's looking at red meat. So we're bringing this technology across into our industry as well. So this is very much a prototype, but anyway, nonetheless, the physics of this, or the measurement, is very accurate. So it looks at the relaxation spectrum, so basically changes the polarity of a lot of the cells in a piece of meat, and then it looks at when that polarity is relaxed. So this is my simple understanding, but this big peak is the relaxation of water in meat, and the small peak is the relaxation of water in the fat. And the nice thing is we've got no overlap between those two peaks. So we simply can measure the amount of water or the energy coming out of that relaxation of water in the fat to give us a measure. Hence why the results for NMR are actually quite accurate. So this is the IMF predicted by NMR, and this is the IMF predicted by NIR on those loins. And this is cross-validated data as well, not just training data. So they cross-validated they taught it on 50 samples and then predicted in the remaining 189 and did 2,500 iterations of that. So this is a really good example of cross-validation. And you can see that the R-squared is quite high and the root mean square of the error of prediction is quite low. So this technology has good potential to be very accurate. So what's happening with it? And Donald tells me the variation could still be reduced because poor old Oscar's been down to the Antarctic and back, and so there's a little bit of oscillation decay, so the magnet's not fully up to scratch in that prototype. But that apparently can be improved without too much hassle. So these guys are now developing their next phase, which is like I think for a paddle technology, which will go against the loin of the lamb or the carcass, and that magnetic field will go through the loin, picking up that same level of excitation and decay from the water. So we're sitting and waiting and hoping on that one that that development, commercial development, is progressing well through COVID. I'm just going to cover off a couple more slides till I finish up. There's a whole bunch of other traits we could measure that we know impact on meat quality, and those are things like IMF that we just looked at with lamb and also beef. But we could have a look at connective tissue. We know that's directly correlated to eating quality, the amount of soluble connective tissue in that, or total connective tissue. The shear force, if we could get a shear force value on every carcass, then you'd put that in the MSA prediction model tomorrow, but we don't actually have one. What about enzyme levels? Maybe that'll tell us something about the aging rates, the water holding capacity of that meat, the sarcomere length, has it been cold shortened or whatever. Fat composition, so the fatty acid profiles, is that going to be the next fad? The nutritional information of the different fats. And we've already got some technologies around that can do that. And what about a rapid genotype? We know a lot about, especially in this country, about the effect of the Bosindicus genes, and there's different calpastatin and calpain genes in Bosindicus. So if we could get a rapid genotype, we could bring those things into predicting eating quality very quickly. But the long and the short of it is we need technology to measure all these traits because the eye can't see them. We cannot see any of those traits. So that's the challenge to any of you young bucks or anyone out there, that we need technologies to measure all of these traits too. So this is a never-ending game and a never-ending challenge or pursuit that we've got in front of us. And it's an exciting one in agriculture for all of us, because the more of these traits we can explain, the better our prediction algorithm can become for both lamb and beef MSA, and then the more consistent product we give to our consumers. For all of you young ones there that are maybe just graduated or thinking about a career in the meat industry, we need heaps of people with very varied skill sets in the meat industry to keep us productive, efficient, moving forward in front of the game. So there are engineers, manufacturers, program software engineers, extensions, journalists, investors, funding bodies, project managers, production innovators, user-face designers, conceptualizers, quality assurance people, logistics, explorers, innovators, and of course, scientists and researchers. So if you think there's no jobs in the red meat industry, think about this long list here. And Rosie O'Reilly will be hosting a virtual careers expo with a lot of meat companies over the next couple of months. So keep a lookout for that one because the range of jobs in the red meat industry is huge, and it's changing daily with all of these different technologies and all the systems that need to be supported around them. So in conclusion, ladies and gentlemen, technologies need to be needed, and they need to be commercially relevant. They need to help optimize or advance the red meat industry in some way, and they need to generate greater value along the supply chain. And that needs to be able to be articulated. The beef industry needs technologies to be continuously developed, and the lamb industry, I should have put that there, red meat. And we need intelligent people with the knowledge of ag to drive that innovation. So that's a call to arms for all of you that are at school or at university or in industry. The food production industry, which is the industry we're all in, needs all of us to work flat out on this. Thanks, Kiri.
Great, thanks very much, Pete. And again, as usual, we've had 1,000 questions come at the end. So John Condon had a question, but I believe you may have answered it with your slide just then about what other traits that we could be measuring. And it sounds like maybe the technology is just not quite up there for it yet. So probably a bit of a lag in that rather than us not measuring it.
We know a lot of these traits. We know a lot of these traits have an effect on eating quality. We just simply don't have the method of measuring them yet. So there's a few technologies out there to measure fat composition, and the SOMA do that in the Japanese beef industry. They measure oleic acid, so that's 18.1, and that's the most common unsaturated fat. But a lot of these others we don't. We can do this in the lab. We can do all of them in the lab, but they're slow and expensive.
Okay, so just a few more questions, and Jasmine, this one might be for you. Or is there any way of integrating that camera that you're probably talking about with completely automated systems? Like, how far along do you see that being a case where maybe your MSA graders kind of overseeing the actual automation instead of physically using that camera?
Yeah, maybe more in the lamb industry. We could get robots to cut those loins and then look at the loins, and maybe in the beef industry too. But while ever meat colour is important as a marketing trait, we've got to allow that to bloom. And while ever humans are quartering those carcasses, we're going to have problems with uneven surfaces and slumped fat and all of those things, which is the importance of the grader to be able to override some of those camera inputs in those instances.
I'd probably have to agree with Pete there. In sort of when you're dealing with lambs, you're dealing with a much more consistent type of carcass, whereas we get a lot of variability in the size and shape of our beef carcasses. So it does definitely present a lot of challenges around automation of that. But as Pete mentioned, obviously we need lots of new people coming into industry, and if you've got a particular interest in robotics and automation, and you think you've got some ideas of how you might be able to actually help our industry, we'd definitely, I'm pretty sure there'd be lots of people out there that would be keen to talk to you, because if we can come up with ways of, particularly around a lot of those jobs that are high risk jobs with bandsaws and things like that, if we can take people out of those high risk areas and make it a safer place for people to work, that would sort of be a real benefit as well. And I think then the automation of that eventual grading process might also come into that as well. But
yeah, no worries. And I'll just one more question, Pete. The Hennessy grading probe was trialled years ago to assess marbling in beef. So from memory, it could accurately assess marbling through the eye muscle, but it came down to a sampling issue. Do you see any troubles with OCT? Same kind of issue as that, or?
It came down to a sampling issue. How well a single? Yeah. So and Rob's on here, so he might like to make a comment about what their commercial setup will look like. But I think commercially that it'll be multiple probes going into the loin at the same time. So this was just a prototype that had come out of the medical field, and so you don't want multiple needles into your brain at the same time. So For the development phase, we just used it and we inserted it up to 10 or 12 or 14 times. I think for the commercial thing, the needles will be a bit more robust and there'll be more of them.
Yeah, and Rob said, yep, sampling may be an issue. Currently building a probe with several needles.
Yep.
Sounds interesting. Jasmine, just another one for you. Do you think that this would push you into, I know that Teaser's talked about it, but maybe into more of the value-based marketing type of scenarios, and it might be a whole webinar on its own. But do you think that having this would certainly help you push that way from where you are now?
I think being able to provide that consistency around that collection of that grading information is a really important first step. And I think the beauty of these cameras and being able to collect some more information off those data points like that ribeye area actually opens the door for us to be able to use more objective technologies around things like yield measurement, which is something that there's obviously quite a lot of research going into, and that would definitely be another webinar in itself. And ultimately, I think that's once you start capturing, obviously the Carcass value is related to both quality and yield. We've got a pretty good handle on quality through the MSA system, and this is just really improving the consistency and accuracy of that data collection. And then I think once we can combine that yield information in there, I think there's some real opportunities there in how we measure that. What that looks like for beef and lamb, I think might be slightly different, because again, it's about how you actually then can capture and monitor those cuts through the bone room to make sure you're getting that correct outcome at the end. And but there's definitely a lot of work happening in that space, but definitely a lot of fundamental research work that's got to happen to bring all of that together.
Yep. Given the time, we might leave it there, and we're losing a few people that probably got other online meetings to go to at this time. But I'm wondering if maybe we might be able to take some of these questions and actually put together a bit of an FAQ, so when we load it up on the website, we can actually answer some of these questions as well that everyone's had that we didn't get to and that we've had throughout. So I just wanted,